Hello there ladies, gentlemen, boys and girls. My name is Anna and I'm here today to do a demonstration and explanation of my inverter circuit. An inverter basically takes direct current electricity, like from this computer power supply, which is currently at 6 volts, and then basically chops it up into pulse DC, which can be put into a transformer. What comes out of that transformer is actuating current, which can run to yet another transformer to be stepped up, and that can run down and power things like high voltage AC appliances like lights. It can also be rectified back into DC. In this situation, it's rectified into a much higher voltage. You can see there's a multimeter which will show us the voltage on the DC side. So basically here I've got this improvised switch that switches on the negative from the emitters of these two transistors. These two are of course on the low voltage side. But the transistors have a 680 ohm resistor on the base to keep everything in check. And the wiring looks a bit like this. The positive 6 volt goes to the center tap of the transformer, and the two other taps run current to these two transistors, which allows you to get, basically an AC waveform out of it. When these transistors switch on and off, they create an expanding and contracting magnetic field, which allows the coil on this end to energize and de-energize, in turn inducing a current in the secondary windings, which can then be stepped up. As you can see here, a light switches on because of that. In basically all situations, DC cannot actually operate a transformer, so the fact that we're getting light out of this thing is actually, evidence that we actually are receiving current from these transformers. And if you look over here, on my full bridge rectifier I have 94 volts DC, and this system seems to produce about 150 volts AC as it is. When I take off the light it will screech like hell, and it is to a degree current limited by the way the transformer is wound, so that way we shouldn't have to worry about any sort of problems when it comes to the power supply cutting off due to overcurrent. Anyways, ladies and gentlemen, that's all for now, and this is just a demonstration of my inverter. I will, in the second section, go on a bit about the theory of the inverter and give you a circuit diagram of it.
Well, okay, ladies and gentlemen, I'm going to go ahead and build the circuit in Crocodile technology and provide you with a bit of a demonstration in a simulation form that should hopefully provide people with a little bit more information about the circuit. So basically what you'll need to first of all get a transformer with a center tap. Now with this particular circuit you may be able to get away with a little cheat, which would be getting two transformers of basically the same size and then making sort of a center tap by hooking them both together. In Crocodile technology this is the only option you have. And I'm not very certain whether or not you can do this in real life, but you can in Crocodile, and I haven't tested it, so I don't know. What you'll then need are two transistors. Now, for those who don't know, transistors are basically transforming resistors. They switch on and off when you put power into them. So what you need to do is hook up these lines to I believe it's the collectors of the transistors. Then you'll need to hook up the emitters to the negative, or I should say the ground on the battery that we're using. Now, when it comes to this particular inverter circuit, you're not necessarily limited to just a battery or a power supply. I mean, anything that can supply a decent voltage and a decent current should be able to power this circuit. Now, because of a bug that occurs in this particular piece of simulation software, I'm going to be putting a resistor in line with the center tap of the transformer due to the fact that there's just bugs with this piece of software because it's really old and computers are stupid. Now I'm going to wire up the bases of the transistors to opposite sides of this system, or of this circuit I should say. That's going to be a little bit harder than I would have expected. Just delete this. Do down here, up here. Like so. Run that through. And like so. Now what you'll see is that there are a bunch of flags flashing on and off and going up and down all over this particular circuit. And that's a good sign because it proves that the circuit is actually working. Now, I'm not 100% certain precisely how this circuit works. I mean, I don't have, qualifications in electrical engineering, nor do I really understand the physics behind it. But there are a few pieces of advice that I will, however, give. The first being that you need to be careful with this particular circuit because it can supply a combination of volts and amps that can, simply put, just kill you. I mean, if you touch this circuit and if you step the voltage up to something reasonably high, like say 100 volts AC, and you'll be able to provide, it'll put out about maybe 100 volts AC and well over 50 milliamps. So be careful. This thing could probably stop your heart, damage your nerves, or kill you if you come into contact with the high voltage side of the circuit. Good way to avoid that is to simply not touch the high voltage side of the circuit or the high voltage side of any inverter. Above all, just use your common sense. Another piece of advice that I'll also like to give is that you should heat sink your transistors because they'll get hot and the thing just runs so much better if you put a heat sink on them. And another thing that I also would mention, you could probably substitute the NPN transistors for N-channel MOSFETs. However, I haven't tested that, and I don't know how well that would work, but if it does work, I'd imagine that this system would provide quite a bit more power than the NPNs could provide. That's all, and I do hope you guys enjoyed this video, and like, comment, subscribe, and feel free to comment below, ask questions, or share this video.